Hello everyone, my name is Rafael, I'll be Mike. Today we're going to talk about OpenShift, deploying OpenShift with VMware CAS, Cloud Assembly, or vRealize Cloud Services. Right, this is the agenda for today. I'm not going to read the agenda, but we're going to go through a lot of code and workflows. First things first, introduction. My name is Rafael Brito. I joined VMware pretty recently, beginning of 2019, as an architect of Office of CTO. I'm going to talk a little bit of Office of CTO organization side of VMware. I joined as architect. Prior VMware, I worked for Citigroup, where I was a global engineer manager for Grid and the entire container systems, including OpenShift. So at Citi, we start from 0 clusters to more than 40 clusters with hundreds of thousands of pods running. My background is containers, OpenShift, Grid. I used to work for New York Stock Exchange, so I have a background in high-frequency trading too. And I'm a Linux guy. I started with a sysadmin. You can leave a sysadmin, but sysadmin never leaves you. So that's how I started my career in the 90s. I'm from Brazil. I used to live in New York for 12 years. Now I live in Austin, beautiful Austin. My hobbies are, I'm a dad ops. I have 2 boys. And a soccer fan, like any Brazilian. If you want to talk about soccer, we can talk. And I'm a home brewer and a runner. Some say like, what? Yeah, they go together. I run to homebrew and a homebrew to run. So I'm going to pass to Mike for him to introduce himself.
Hi everyone, my name is Michael Patton, and I am a advanced customer engagement architect with VMware. I've been with VMware 8 years now, and primarily I work within the vRealize space. I've been in IT for quite a while, and a longtime champion of VMware. You can reach me at Twitter at vmichaelpatton1, and also vmw.solutions. I'm excited to be here, and thank you for attending.
As I mentioned, we're going to show a lot of code, so don't freak out, because you can download all this code from this Fling. And I have this slide in 2 places, in the beginning and the end. So who is familiar with Flings? All right, so Fling is a way that VMware drop code, experimental code, laboratorial code. So there's no support, it's not part of a BU per se. So we developed this Fling, which is a VRO package. There's a documentation how to install the package. And has the copy of the scripts that we're going to go over today. So you can go ahead and download it. So disclaimer is this Fling is for 3.11, OpenShift 3.11. The Fling for OpenShift 4 is in the works. But is a Fling, I don't have a date to give you. I give an email. You can email us. Then we can drop some of the codes that we have, because OpenShift 4 is very different. And I have a couple slides about OpenShift 4 and why it takes longer. It's just a different animal. I'm going to pass to Mike to start how we're going to start this journey. On the clicker.
Thank you. All right, so with our familiarity with OpenShift, we know that there can be complexity in installation. And what this session is all about is that end-to-end process. And we start by acknowledging the problem. The problem is that we have complexity and inflexibility for the installation. And the solution is, what we see is, to overcome those, we have automated the end-to-end process. And when I say end-to-end, I mean starting with a base template, all the way through the installation and for you to be able to log into the portal for OpenShift. So with that end-to-end process, we believe we have a great solution to offer that addresses these complexities. The goal behind this session is to talk about how we bring down silos. And there's 2 personas that is talked about, both from the OpenShift perspective, maybe this OpenShift admin, and then also the cloud admin being represented by myself. And historically, that barrier, that miscommunication between these 2 groups of of people have created issues. And what we hope to do with this fling, and we believe we accomplish this, is that we bring down this barrier by providing that end-to-end. So now the developer and the cloud admin have a common space, and that silo being brought down, and leveraging this automation of OpenShift builds that bridge. We see this bridge being built in two ways. We see the OpenShift installation in a full production HA environment, and that's also supported by, let me go back here, by the infrastructure. So there's actually two parts to this. We have the infrastructure, the automation that supports that end-to-end installation of OpenShift. And we'll be going through both of those. We'll see Rafael go through part one to talk about the OpenShift deployment layers, and then also I'll be following up with the automation components that allows that end-to-end process to take place. As just a brief high-level overview of what this process looks like, we begin with a self-service portal. Now the self-service portal is vRealize Automation Cloud. So if you're familiar with vRealize Automation, that's our tool of choice in this example. And so we go to this portal, and by authenticating in, we have a service catalog. And in this service catalog, we can then select the blueprint for OpenShift. And in selecting that, we have three components. We have the governance, we have the tagging, and we have the compliance. All of those go in combined to be able to provision the VMs necessary for the OpenShift installation. We have two options for our workload placement. We have chosen VMC, VMware on Cloud in AWS, or on-prem within the SDDC vSphere environment. Those are our two supported environments now. And so as we deploy these VMs to these, each of these environments, what we see is an orchestration process by utilizing vRealize Orchestrator and or CloudInt. You could orchestrate this in many different ways. What we've chosen is vRealize Orchestrator, and we have then the operating system as well as the application ready for deployment, which then kicks in the OpenShift installation. And that OpenShift installation is leveraging Ansible as well as the binaries for OpenShift, which then gives us that cluster component. And what you'll see in the architecture is that we have a full cluster. We have 3 HA proxy, infra, 1 admin node, all of these different components there. So this is a full-blown HA environment. So that cluster exists to support your K8 environment, and it brings that portal for OpenShift. And this is what you're going to see throughout this entire process. Okay, what I'll do is I'll transition now for OpenShift over to Rafael.
So before we go to the infrastructure, it makes sense to understand how OpenShift operates. So we can talk about infrastructure in the second part. So this part is more a level sync about OpenShift and the components and how we install and use some of the code to help the installation. I'd like to ask first, who is familiar with OpenShift here? Okay, almost everyone. Who is familiar with OpenShift 4, which is the new one? Okay. Migrating to 4, okay. Okay. So for the level of the level sync, talk about OpenShift, which is Enterprise Kubernetes by Red Hat, but it's not only Kubernetes, it's a full pass. It has the CI/CD, which has the Jenkins, it has the source to code. You just point to your GitHub, it compiles for you, deploy, and you log in on the first time, you see a nice catalog about Perl, Python, all this good stuff. Has Elasticsearch for the log aggregation, has a Docker registry. It's really a lot of components coming with OpenShift. So it's not only Kubernetes, right? 3.11 is installed and managed by Ansible, right? The most used, everybody uses 3.11. Back at City, we're still using 3.11. In OpenShift 4, we're going to talk about the differences, the challenges. We're going to talk a little bit about the challenges. I can talk to you if you have more specific questions after the session. But the latest one, I think OpenShift 4.2 was released last month, right? It's based on Kubernetes 1.14. the scope is 311, but every time we're gonna mention about OpenShift 4, okay? Right, talk about components. So every cluster has a master, and Kubernetes community called control plane nodes. OpenShift uses master, right? It has the API, has a scheduler controller, and has a TCD. Then OpenShift has this concept of infrastructure nodes or infranode that's going to run a very special pod called router, which is one of the main advantages of OpenShift, right? You set up a wildcard DNS, launch the infrastructure nodes, and the user has the ability to come up with a URL or a route for them. The app node, which is in the community, we call workers. Actually, in OpenShift 4, they start to call workers, not app node anymore. It's actually where the application gonna run, your pods. You have the admin node, which has SSH and Ansible, how you're gonna install cluster. And you can optionally bring your load balancers. OpenShift 3.11 install a load balancer for you if you have a VM. But you can use any load balancers. Back at City, we had the largest NSXV load balancer deployment of the world, and 300 load balancers just for OpenShift. I'm gonna talk a little bit about OpenShift 4. OpenShift 4 by default doesn't have infrastructure nodes. It's optional. But I do recommend you to set up some worker nodes as infrastructure nodes. It doesn't come with the role, but there is, if you look at the documentation of 4, they tell how to set up. It's a post-install setup. That's a challenge. That's when the Flink before it's not ready, and honestly, all these challenges make that it's not a migration to want to be, right? So we have to set up the infrastructure nodes as a post-install. I'm gonna walk over a cluster, how a big cluster, and that's good for 3.11 and 4 too. How we set up in City to be a very secure, very good for power any very important app in production. So everything starts with the VI admin, the virtualization admin, which will be the case from Mike. They have the setup, have your internal cloud, and the OpenShift admin comes, hey, I need to install an OpenShift. So it gives the specs of the nodes. We have a slide about the specs of the node. And the VI admin or your internal cloud comes and deploy the VMs for you. In this case, we got 3 masters recommended. Remember, this is to power a very important app or many users. So 3 masters, 3 infra nodes. The number of the app nodes really depends on the business appetite and the size of the wallet. You can do small, you can do super big, and the admin node. Back in City, we had AWS clusters with 1,000 app nodes, and it was super expensive. Then the OpenShift admin comes, install, there's SSH, install Ansible on the admin node, kicks off the installation. Then after the installation is done, we got the masters up, we have the API traffic. Then the infra nodes are up as well. They are the routing layer, which the ones that are gonna interface with the outside world. Then the app nodes have the service layer. The nodes talk to each other over a load balancer. So that's the first load balancer. We call internal load balancer. OpenShift 4 is the same concept, okay? And actually OpenShift 4 requires a very specific DNS entry. For here, you can come up with any entry you want. Optionally, and recommended, you can put a second load balancer on external, so we can segregate this traffic. And this optional external load balancer has a great advantage that you can install your own cert, like mycompany.com, because for the internal traffic, the SSL must be passed through. And by the way, in OpenShift 4 is the same, right? You have a different DNS entry for the. You can point to the same load balancer, but what I'm suggesting here is have 2 separate load balancers. This can do micro-segmentation as well and so on. Have a third load balancer for the infra nodes. Again, you can put your own cert over there, and that's where your users and the internet, whatever they are, they're going to reach out your applications running on the cluster. Let's talk about node sizes. Those node sizes are for 311, good for 5,000 to 10,000. They are good for OpenShift 4 as well, with one difference that they're going to talk about it. So this master, 3 masters again, like 8 CPUs and 32 gigs. Remember, etcd, it takes processing, especially when there's a lot of operations on the cluster. This is the infra. This is for 311. On 4, if you want to set up an infra node on 4, it's optional. And if you want to have Elasticsearch running on the infra node, then you have a bigger spec than this. Because the Elasticsearch on 4 is 16 gigs by itself and has 3 copies. So that's why I didn't put it here, because there's a lot of, it's really an optional. But for this sizes, without Elasticsearch running on that node, that's enough for 5 to 10,000 pods running. That's the admin. NHA proxy, again, is optional. If you don't have a load balancer, people use F5 and SXV, you name it. But if you don't want to depend on anybody else, you can carve VMs. Those sizes are fine. Then they're going to act as a load balancers. And our Flink, by the way, set up the VMs for the HA proxy. We're going to talk about it. App node sizes, it really depends on your app type. The minimum is 3, maximum is 1,000. Like I mentioned, we call this a horizontal size. The vertical size, actually the specs of the VM, that's the minimum that Red Hat recommends. And the maximum that we recommend is up to a NUMA size. Actually, the perfect that you put like a factor just to give some headroom for vSphere. So we kind of recommend 0.85 times the NUMA size. That's going to avoid a very large, well, we can even say that the size of the NUMA is large enough. But depends on your nature of your application. But at least putting in a NUMA, you're going to have a better performance and better DRS. Let's talk about the code, right? To install 311, it's all on Ansible, and you need to create an Ansible inventory file. I think there's like almost like 100 parameters you can add on the inventory file, and that's one of the reasons that perhaps Red Hat went to OpenShift 4 and dropped all this, because it was giving so many options to the users. But for this Flink, what we did is we had a Jinja 2 template file for the inventory file. And we have a naming convention for the VMs, so we can populate, create the Ansible inventory file based on this logic and for those parameters. Say that again? Exclude? It's just a file. It's just a file that you just run Ansible, and that's it. You don't have to install anything. But you can come with your own template if you want. So in this solution, and Mike's going to talk about it, it starts with a blueprint. The user types in like parameters like the cluster name, your login on Red Hat. So there's like a handful of parameters that the user puts in and instantiate the cluster. So those parameters are here in a YUM file on the admin node. So for me, remember the slide of the silos? I told Mike, I just need those parameters to populate my inventory file. So he created the blueprint. The user put the cluster name, test 1, test 2, test 3. You need a login on Red Hat so we can download the packages, pool ID, and AD parameters if you want. So this comes like in this format on the admin node for me. Then I'm gonna run a script that's gonna create the inventory file. But before I run the script, the inventory file, the VMs are created following this logic with the cluster name as a metadata. So what I'm gonna get, what I'm gonna look, it's those 13 VMs, and I have master 1, master 2, and so on. With all those, including the 3 load balancers, and on purpose, I'm kind of eating my own dog food here. If I recommend 3 load balancers, I'm creating 3 VMs for 1 each load balancer. The HA Proxy 01 is the internal load balancer. HA Proxy 02 is the external load balancer, which, by the way, OpenShift Ansible installation does that for you. In OpenShift 4, you're out of luck. You have to do all this. And I do an OpenShift, I do an extra post install that I set up the HA Proxy 3 for the infra nodes. That I had to do myself. This is the Jinja 2 template. And it's just a file. And you see here, I know it's small, but again, don't freak out. You can download this. I can give you the link so you can see yourself. But inside of Jinja 2 files, you just need those parameters coming from the OCP parameters from the blueprint. Yes? Huh? Signs? Well, I didn't put on this, but you can download and change this code and expand for the cert is going to be a file here on the admin node. So you can put on a vault or something and put a code to do not wget, but whatever, and put over here, and on the side of Jinja 2 template, you add a line and where to look at to the cert. What I want to call out here on this template on the Fling is the hardening Docker and hardening etcd. Because most people, especially the security folks, they love that. They come like, you need to harden your OpenShift environment. But if you go, they give you the Docker CIS benchmarks, standards, but they don't tell anything about OpenShift. You need to actually look at the Kubernetes CIS. But for the Docker, they give it as a standalone Docker. So these lines here that you see, it's kind of like trying to accommodate all the CIS security practices and keep OpenShift happy. And etcd, disabling all the not super secure ciphers. And this Fling as well, we enable audit, advanced audit, which is not by default, which is another tricky thing to set up on OpenShift 3.11. Right, another secret sauce, which is not that secret in this Fling, is the Ssh Equiv Helper. That's how we're gonna automate Ansible to be functional when you instantiate the VMs. And Mike gonna explain on VRO workflows, but when the VMs boot up, they run a wget to the admin node to grab the pub key. So the Ssh Equiv is gonna happen. And the installation only gonna happen if Ansible pings every node of the cluster. And that's how we made this loop in the timer to make sure the VMs are up, they wget the SSH pub file, and get on. I use the same practice for OpenShift 4. If you guys are familiar with OpenShift 4, you need the web server to install OpenShift 4, because you need to stick a config file and as an attribute as a VM. So you need, and this attribute has a link to a wget. So I'm kind of leveraging the same for OpenShift 4. Here's the install, how to install OpenShift after all the VMs are Ansible pingable. Not only all VMs, the HA proxies, the DNSs, everything gonna be pristine to run OpenShift. Because if you have a problem of networking, like have a dup IP or something, OpenShift installation gonna fail in a cryptic message, you have no idea what's going on. So those are the command lines. Before I hand over to Mike, I'm gonna just spend very briefly about OpenShift 4. I stick those slides just this morning. It's a lot of text, so bear with me. So those are the differences between OpenShift 3 and 4. So all the automation I've done on Ansible for 3, pretty much they're done. You're not gonna use that anymore. Because now everything is machine sets, The installation doesn't use an Ansible. You configure your nodes. They are CoreOS. Of course, you can use Rail 7, but the bang for the buck is really machine sets to set up stuff like SSH, CRYO. You now are all objects on Kubernetes. Another big change on OpenShift 4, there's no more OC commands on the masters. So if you have a lot of automation to do post install, creating admin, and so on, if you put on the masters, there's no more OC over there. So there's the log configuration is a post install. The LDAP is all over operators now, and CRYO, right? It's a default. I couldn't even get the Docker hardening over CRYO because CRYO is listening to a port, and like security is not gonna like it, listening to a TCP port. And some of this traffic is over TCP 6. So for many, many reasons, the Flink, I don't even know when this Flink is gonna be released because we have all these differences. There's some gotchas as well. I mentioned about it. For OpenShift 4, you need DHCP for 1. I think for 2 they changed that, but you need DHCP, you need DNSs, you need load balancers. You need to configure load balancers before, during, and after the installation. Not a simple thing, in my opinion. Okay. You have the bootstrap node. You still need an admin node, in my opinion. It's not clear if you need an admin node, but you still, in my opinion, you still need an admin node to run command lines, to SSH, to generate the config files from the installation. The bootstrap node is just ephemeral's VM. You create, you just bootstrap the cluster, then you get rid of it. All right, so that's my part of OpenShift. I'm gonna go back in the end, explain a little bit more what's next, but then I'm gonna hand over to Mike. Where's Mike? Ah. Right there.
All right, so now we're going to look at the infrastructure and the automation that's going to make this happen. All right, so important is design and assumptions of how did we come to the solution that we did. And with that, what we see is, I'm just going to build this screen out. So what's important here is that we had 2 solutions. We had first, because this is version 1.1 of our alpha. We did have a 1.0, and that was on VMC. And so with VMC, the same process that you would deploy in VMC, we just now, for 1.1, we now have for the SDDC on-prem vSphere. And so with that, those were our 2 main decisions. Those are our 2 cloud points. As I talked about earlier, our workload placement is in those 2 locations and supported. So when you download the Fling, the same blueprint, the same orchestration will all be applicable to either one of those environments. Okay. So the next, this just illustrates that again. We're deploying out to vCenter both in VMC as well as on-prem. One of the most important things, and you think about the end-to-end process, the most important thing is how do we get IP addresses, how do we get DNS registration, and how is that automated? And so in this case, with DNS, we had basically 2 options. In this solution, we're leveraging DHCP, and within DHCP, we're basically doing PowerShell scripts for the DNS registration. If not a lot of companies can leverage dynamic DNS, so what we've accommodated is for the scripts, and I'll show you those workflows in just a few slides, that once you go ahead and register in DNS, we prescribe the host names, which is very important because remember, when we have the admin node needs to go out and find the HA proxy node, the app node, and things related to that, and vice versa. So they all have to be able to find each other, and so naming and registration is extremely important. And the other aspect of DNS is the aspect of the subdomain, the cluster name, and that is reflected in DNS as well. And so all of that has to be dynamically created, and we do that in our VRO workflow. And the last point on this slide is that if you don't have access to DNS, you'll just need to statically configure these components in DNS. So, but the PowerShell scripts using a PowerShell host will be able to do that for you. So as we talked about, the blueprint and other configurations is vRealize Automation Cloud, or well, that's just vRealize Automation Cloud. And so what we see here is this is an example of what that screenshot looks like. I know it's small, but I'm going to focus in on it and show you. And we have a blueprint that is both with or without Cloud Int. Now, this is important because you don't have to recreate this blueprint. It's within the Fling. You just download the YAML file, upload it into VRAC, and you have your blueprint. So there's no configuration necessary. This is another one that I'll go ahead and focus in on without Cloud Int, but this is an example of what a single blueprint machine, because remember we have 13 machines that we're dealing with. This is an example of the admin node, and we see it begins with the cloud vSphere machine, and we have all the network, customization, host name, all of these are the variables that you would then leverage as part of your parameters that you deploy the machine with. So you basically just complete a request, which would have all that information, such as two examples, your Red Hat subscription and password. That would just be one example that we see here. And once you have that filled out, then you'll kick off the installation. And so when we have orchestration within vRealize Orchestrator, it's important to note that for these workflows to kick off, you have to have event subscriptions. And so after the machine is deployed, there's a number of different scripts that kick off. So the first script that kicks off is the VM set name. So we need to very specifically prescribe the VM name necessary. We want to control that as much as possible because they have to find each other, DNS registration, and so forth. So this is our first script that gets created. The second script that gets created is the larger workflow, which we'll do a deep dive into, that has all of the different components, registering DNS, making sure VMware Tools is installed, and so forth, and the installation of the admin node, and therefore. Now, I do want to focus in on this condition in the subscription, which is very important in VRO, because when you have VRAC, you may have multiple blueprints, multiple machines, and so one of the things that we control here is a condition, and we set a true condition to a OpenShift, enable OpenShift variable. And so long as that variable is within the blueprint, that enables this workflows to run effectively. So it's a way of filtering and control. So you don't, yeah. And then the last one we have is the deregistration process, because remember our end-to-end process for automation is you build the environment, well now you have to tear down the environment. So we basically uninstall, we basically remove the DNS entries, including the subdomain for the cluster as well. So those are all components with that. And in the white paper, we talk about some of the tips, tricks, and gotchas that can take place with that. And so that's good information. All right. So going back to our workflows, this is an example of the VRO workflow set VM name. And what you'll see in the bottom right-hand corner of your screen is basically the JavaScript that allows us to basically set that name that's actually prescribed. What you'll see is that there's an admin 01, well it's actually cluster name admin 01, cluster name HA proxy 01, 2, and 3, and so forth. But the set VM name kicks off as part of that process. So the next workflow is the largest workflow that we have, and I'm going to focus in on each one of these sections next. But what we see here is overall, we begin in the upper left-hand corner by getting the VM details. Those are all the parameters that we kick it off with, the cluster name, subscription for Red Hat, and then we go into obtaining the IP address, making sure that VMware tools are running, and then it goes through. But this is our end-to-end process, and at the end over there on the far right, you will have had an installation of OpenShift. All right, so here's where we see the deep dive on the different components. So we start out with the properties, we get our IP address, but what's really important about these VRO workflows is that one, we need to make sure that there's a number of circuit breakers that if a machine for whatever reason doesn't get an IP address, you know, we break out of that circuit, we break out of that workflow. And so you see the IP address, but then we see register DNS. If you're not able to register DNS, we break out of that as well. So we have these different places that checks and balances. And then over on the right-hand side, what we see is because we run the scripts in guest, it's important that we make sure that VMware tools are running. So that's another wait condition that we're relying on to make sure is up and running before we continue. With those in place, we now have the ability to pass our parameters into the generic host preparation. And this begins the bash script installation on all of the nodes, the HA proxy, the apps, all of those. And we prepare the nodes. And so that's installing Docker, that's getting ready for transferring of the pub SH, all of those different components. What we see in this next session is there is a decision point on the left-hand side that says, is it the admin node or isn't it? So if it's not the admin node, it's going to be the HA proxy or the app or the infra. And so we see from the admin node, we start to kick off all of the different bash scripts that prepare that server. So we would have already had Docker installed on all the hosts, but now the admin hosts is going to set that SSH equivalent that Rafael talked about before. So now we're going to start to set up for Ansible, and Ansible relying on SSH, we're now going to automatically set that up. And so with these scripts that you see all along the admin node, basically sets that up. And then from the HA proxy side, these workflows here on the bottom left are actually in a wait condition because the admin node keeps checking in to make sure that the HA proxy and the infra and the app nodes are up and running before proceeding. This is just a workflow number 3. This is our deregistration process, which just basically backs out all the DNS entries and the destroying of the VMs.
Yeah, when you be able to create the cluster, but when you delete the cluster, all the VMs are gone as well. So the good about this solution that you can keep creating and deleting and so on.
Thank you. Okay, so this example here is just what you have is the registration and deregistration of DNS, which in essence for all 4 scripts, because you have A and PTR records, you have the subdomain, and you also have the deregistration process as well. This is literally just a PowerShell command that registers in DNS. So there's nothing magical about this, but it's fitted within the implementation process for the automation. So it basically registers and deregisters CNAMEs and the A and PTR records. Okay. All right. Now, the generic host preparation file, what we see here is we see the Red Hat Subscription Manager. So that's you're going to populate those variables. Remember, you did that before when you kicked off the installation. All right. So those get populated in. We enable the appropriate repos. You don't want to enable all of them, so we very selectively. And that's also important. The tip and trick here is to make sure that your subscription is tied into the OpenShift repo and you have the necessary. So as long as you have that in place, everything's good. All right, and we see additional components with Docker and starting Docker script as well. Okay. Here we see the admin node setup script, and we'll focus in on a couple of different components to this. But again, this is installing just for the admin node. And we see Python, NFS, all of the different components there. And one of the things that we wanted to focus in on this script was the necessary wait times that this circuit breaker here is that we're making sure all of the nodes are up and running, available, and are ready, because we don't want to go forward until all of those are set up. And so this is an example of what we would see here. We call it the Ansible ping, and it basically makes sure that everything's up and running. All right? And so we basically get back a success, all nodes are up, or not. Okay. And so you'll actually see this run for quite a while as all the other machines come online. So the next script that we run is the SSH setup, and this is where we transfer and start to have the RSA pub transfer to all the different nodes. And you can see that on the right-hand side, you just see a variable with the wget. And so once we have that, then we can be relying on Ansible for the rest of the installation. The last thing we do is on the HA proxy or the infrastructure nodes, we have the configure Docker storage, and that's our last configuration that we do before the actual OpenShift installation. And the OpenShift installation kicks off 3 different playbooks. And within those 3 different playbooks, you'll see, as Rafael pointed out before, it takes approximately about an hour to actually install end-to-end for OpenShift. But again, at the end of that, what you have at this OpenShift installation, we also have, if you log into the admin node, you can tail a OpenShift install script and basically see it just running. And so it's a really good way to just keep tabs on how things are going. And so the last thing you end up with is in VRAC, vRealize Automation for Cloud, is the deployment nodes here. And what you'll be able to do there is to manage them and leverage the application for that. And that's Cloud Assembly. Right. And so what you end up with is OpenShift, and I'll pass it over to Rafael.
Right. Thanks, Mike. Yeah, when you finish all this after 1 hour, you have your GUI. It installs everything by default, all the components. So it's not the Elasticsearch and catalog and so on. Has Grafana, and Jenkins and stuff. So you have a full-blown cluster after you just fill up those parameters and click and wait. Of course, there's a one-time setup. You need to import the package. You need to create the templates. About DNS, we rely on DNS on the environment using Microsoft DNS, but if you want to, you do whatever DNS you want. Again, that's the link of the Fling. And there's a lot of stuff to do, actually, as I mentioned multiple times. So we've done a couple things for the 1.1, but we had a long list, a wish list, and that's the plug about Office of CTO. I work for Office of CTO. It's an incubation inside of VMware. Greg Lavender is the CTO. I'm not part of any BU. I'm not selling. I'm not responsible for vSphere, Enterprise, PKS, whatever. So it's incubation. So all this that needs to be done, there's a wish list as well to have a Flink for an SXT, OpenShift and an SXT, the Flink for OpenShift 4, all this. But I can only put time and effort depending on the customer demand. So please let me know, let your TAM know that you guys are interested. Then we can kind of figure out to see what we can do. All this work is me with Mike. Mike works in a different organization, so we are almost like coming up with this code together. So this is the next step, so call for action. That's the email gonna reach this group, okay? If you look at the blogs, blogs.vmware.com, there's a lot of blogs, right? It's a great source of information. There is an Office of CTO blog, where's the looking forward stuff, and my team created this paper about the application platform architect. Or APA. I'm an APA. So basically it's a new persona in the organization that combines development, infrastructure, and deployment. So it's really an SRE with more spin of developer. And this paper talks about the hybrid cloud runtime. By the end of the day, we need to deploy applications, right? It's not about Kubernetes, a shiny toy. We just need to deploy applications. I have a best practice white paper that is taking forever to publish. Stay tuned. If you send me a note, I can put you on the list. Once it's the release, I can let you guys know. But all the node sizes that I mentioned here, there is stuff about DRS, there's stuff about HA, there is stuff about the hardening that I explained to you guys, and all the stuff that I messed up at City with Kubernetes, especially when it comes to default limits and requests. And there's a nice section about over-allocation or over-commitment, how you can do Kubernetes over-commitment and vSphere over-commitment working together. Of course, depends off your SLOs, right? So that's the paper. If you want, get notified once it's out. Knock on wood, very weeks. I'll let you know. Let us know your use cases with your TAM. Engage your TAM, because that's the person that's gonna be the conduit. I'm not a customer-facing person. Um, well, I'm approachable. But it's not my day job to. If you send a note to me, the follow-ups, the make sure it's the TAM, right? So engage the TAM. He's gonna reach out to me. We're gonna work together and see what we can do. Download the package, and this is my tweet, me and Mike, so you guys can reach out to us. Please, 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 fill the survey. Even if we suck, please go ahead and just fill it and say that we suck so we can do better. Yes, Q&A now. Yes. Do you want to take that? She asked if VRA 7.
Oh, VRA 7. You could, yes. Yeah, we did not test on VRA 7. We chose VRA C because VRA 8 has just been released, and so we really didn't want to focus on VRA 7. So right now I'm working on VRA 8. I should have that validated probably in the next couple of weeks, but that's why so I don't know if that answers your question. But you can use the same workflows for VRA 7, yes.
Any other questions? Good on OpenShift 4? Everybody's ready for OpenShift 4? Huh? For OpenShift 4, as of 4.2, you don't need the direct internet connection. But for 4.1, not even a proxy works. You need to have a direct connection from the internet. So for 4.2, apparently they put a way that you can kind of have a replication of the packages inside of your organization, but you still need to go and download. But the internet connection for banks, insurances, and so on is, I cannot say much, but and then you have to again, I'm not from a BU, I'm not selling anything.